This video explains counting frequencies using COUNTIFs. Cell range A2 to A21 has data, and cell range C2 to C9 has the bins. We will compute the frequency in the cell range D2 to D9. I will do it in 3 steps. In step 1, I will count frequency for the first bin in cell D2. In step 2, I will count frequency for the second bin in cell D3. In step 3, I will copy the formula down to count frequency for all remaining bins. Let's begin with the step 1. In cell D2, enter equals, COUNTIFs, open parentheses, and click on function. You will see COUNTIFs dialog box with 2 input arguments. Select the range A2 to A21 for criteria range 1. Enter argument double quote, less than equal to, double quote, ampersand, C2 in the criteria 1 and click OK. You can see that the COUNTIFs function has returned 4. This means there are 4 values either equal to or less than the 5 in the data array. Now let's move on to step 2. In cell D3, enter equals COUNTIFs, open parentheses, and click on FX. You will see COUNTIFs dialog box with 2 input arguments. Enter cell range A2 to A21 for the criteria range 1. Fix the cell references in the criteria range 1 and make them absolute cell references. Enter double quote, less than equal to, double quote, ampersand, C3 in criteria 1. Now you will see additional argument field criteria range 2. Once again, enter cell range A2 to A21 for the criteria range 2. Fix the cell references in the criteria range 2 and make it an absolute reference. In the criteria 2, enter double quote, greater than, double quote, ampersand, C2. You can see that the COUNTIFs function has returned 2. This means that there are 2 values that are more than 5 but less than or equal to 10. Finally, let's implement the step 3. We can count the frequencies for the remaining bins by copying the formula down the column. Select cell D3 and copy the formula down to the cell D9. You can see the frequencies in the cell range D2 to D9 against all bins. This video illustrates the use of frequency function to count frequencies, and use of unique function to extract unique values, count unique value frequencies. First, let us begin with counting frequencies using frequency function. Cell range A2 to A21 has data. Cell range E2 to E9 has the bin values. In cell range F2 to F9, I will count the frequencies. In cell F2, enter equals, frequency, open parentheses, function. You will see frequency function dialog box. Let us enter arguments, data array, and bins array. Enter cell range A2 to A21 in the data array. Enter cell range E2 to E9 in the bins array, and click OK. You can see that the frequency function has returned frequencies for all bin values. In Excel 365, frequency is an array function. Once entered in cell 3, it will return frequencies for the cell range F2 to F9. In F10, you will find a frequency count of 0. This is called residual count. It is a count of frequencies that are not counted for any other bins in the bins array. All cells in the cell range F3 to F10 should be empty while entering formula in cell F2. If not empty, then frequency function returns #spill error. This is true for all array functions. Counting frequencies in Excel versions other than Excel 365 is cumbersome. If you're using other Excel versions, then you should perform the following steps. Select cell range F2 to F9, click on the formula bar, enter frequency function, and then press keyboard key combination, Control-Shift-Enter. You will find frequencies counted for all bins array values. Next, let's count the frequencies for the unique values in the data array. This must be done in 2 steps. In step 1, let me create unique value bins array using unique function. In cell B2, enter equals, unique, open parentheses, and click on FX. You will see the unique function dialog box. Enter cell range A2 to A21 in argument array, and click OK. You can see unique function has returned unique values in cell range B2 to B16. Now we can use cell range B2 to B16 as bins array. In step 2, let me compute the frequency of the unique value, bins array. In cell C2, enter equals frequency, open parentheses, and click on FX. You will see frequency function dialog box. Enter cell range A2 to A21 for the argument data array. Enter cell range B2 to B16 for the argument bins array, and click OK. You can observe the frequency in the cell range C2 to C16. The zero count in cell C17 is the residual frequency. Residual frequency is the frequency not counted for any other bin values. Once again, all cells in the cell range C3 to C17 should be empty. If not empty, then frequency function will return #spill error. This video covers counting frequencies of survey data using COUNTIF function. In addition, we will show how to compute relative and cumulative frequencies. Cell range A3 to D10 has survey data. Note that data is in the form of text values. And cell range F3 to F7 has the bins. You will compute the frequency in cell range G3 to J7. Let's begin with counting frequencies in cell range G3 to G7. We will use COUNTIF function. In cell G3, enter equals COUNTIF, open parentheses, FX. You will see COUNTIF dialog box, which has range and criteria as arguments. Enter cell range A3 to D10 for range, and make the cell references in the cell range as absolute references. Enter F3 in the criteria, and click OK. You can see COUNTIF has returned frequency of 5 for excellent. This means there are 5 excellent responses in the survey data. Copy G3 cell formula down to the cell till G7. You can see COUNTIF has returned frequency counts for all other bin types. Now, in cell G9, let me compute the total of frequencies. I will use sum function to sum the cell ranges G3 to G7. You can see the sum of the frequencies. It is the total responses in the survey data. Next, let me compute relative frequency in cell range H3 to H7. Relative frequency is the bin frequency divided by the sum of the frequencies. In cell H3, let me construct a cell formula to count relative frequency for excellent. You can see the formula has entered 15.6% as the relative frequency for excellent. This means 15.6% responses are in the category excellent. Let me copy the formula down to H7 to compute relative frequency for all other bins. Now you can see relative frequency for all bins. Next, let me compute the cumulative frequency in the range I3 to I7. Cumulative frequency for a given bin is the sum of the frequencies up until that bin value. Excel doesn't have a separate function to compute cumulative frequency. Instead, we have to use sum function. In cell G3, enter sum function with range argument as $G $3 G3. Notice the absolute reference in the first cell reference is the argument cell range. This allows us to compute cumulative frequencies for all bins at once by copying the formula down the column. You can see sum function has returned 5 for excellent. This is the same as the bin frequency. Now let me copy the formula down to cell I7. You can see the sum function has returned cumulative frequencies for the rest of the bins. Also, you can see that the cumulative frequencies are not the same as the bin frequencies. Notice that the cumulative frequency of the last bin is the same as that of the total responses in the survey data. Lastly, let me compute the cumulative relative frequency in the range J3 to J7. In cell J3, enter a formula to divide cumulative frequency of the bin by the total frequency. I'm going to enter the formula equals I3 divided by $G $9. You can see the formula computes the relative frequency for excellent. Now I can copy the formula down to cell J7. Now you can see the cumulative relative frequency for all other bins. Notice that the cumulative relative frequency for the last bin is 100%. This video covers graphical representation of frequency distribution. Cell range A2 to A41 has data, and cell range F2 to F6 has class intervals. Class intervals are the bin values. In cell range G2 to G6, I've already computed frequencies. And in cell range H2 to H6, I've computed cumulative frequencies. We will cover two types of graphical representations. First, the histogram, which is a collection of bars. Each bar is a bin, and the height of the bar is the representation of its frequency. Let me select cell range A2 to A41. Click icon Insert Statistic Chart located in that group chart under the tab Insert. Let me select the first chart under histogram. Now you can see the histogram. Notice that the class intervals are different. We want the class intervals to be the ones in the cell range F2 to F6. Let me change the class interval. I will double click on horizontal axis and click on axis options, and then select radio button for bin width. Here, I will change the bin width to 8 and close the pane. Now you can see the histogram with the class interval as given in cell range F2 to F6. And the bar at the middle is the tallest bar. This means more observations are crowded at the center than in the extremes. Next, let me draw the cumulative frequency curve. Cumulative frequency curve is also known as ogive. It is a typical ogive graph. Y-axis represents cumulative frequencies, whereas the x-axis represents class intervals. Let me select cell range F1 to F6. Press Ctrl and select cell range H1 to H6. Now let me select line chart with markers under area chart on the Insert tab. You can see that the cumulative frequency line is plotted. Cumulative frequency chart is always trending upward from left to right. However, the degree of its steepness or flatness is determined by the distribution of frequencies.